Welcome to this new chapter. It focuses on the determinants of matrices. So here we have to find the determinants of matrix and also use different techniques. Explain how you can find the determinant of matrices using different techniques such as Gauss reduction or normal expansion. So if you are giving a simple matrix, a 2 by 2 matrix, 3 by 3, 4 by 4 matrix, and so on, or n by n matrix, the question here is, what is the best way for you to find the determinant of that matrix? And the first thing I would like to highlight here is, we can't talk about determinant of a matrix when it's not, the number of rows is not the same as the number of columns, okay? So if I give you a 5 by 4 matrix, then you can obtain a determinant of such matrix. You can only obtain a determinant of a matrix where the number of row is the same as the number of column. So having said that, if I give you a simple matrix, if I call a new matrix, and if I ask you to find the determinant of this matrix, I think this is a very simple case. So we just have to multiply these two, we subtract this product, okay? So this is basically A times D minus B times C, okay? So this is called the determinant of A. All right, you have different way of notations of the determinant. You can either say determinant by writing this, determinant of A is equal determinant of A. So the two bar here represents the determinant notation, okay? So having said this, you see any example of a 1 by 2 by 2 matrix is very simple, it's straightforward. So as an example of a 2 by 2, let's look at this. This is the first example, example 1. If you are giving this matrix 1, 2, 3, 5, it's just an example, okay? So, and you are asked to find the determinant of this matrix. What is their value? So you cross multiply, we apply exactly what I explained here. We cross multiply, we multiply 1 times 5 minus this, so this is 1 times 5 minus 2 times 6. This is 5 minus, sorry, this 2 times 3, this 5 minus 6, and this is minus 1. This is an example of a 2 by 2. Now, what happens if you don't have a 2 by 2 and you have a 3 by 3, 4 by 4, 5 by 5, up to n by n, and you have to find the determinant of such matrix? How do you proceed? First of all, you have to fix the row or the column and expand your matrix, your determinant following the row or the column that you have fixed, okay? So you have to choose a column or a row. It's a very simple principle. If I say for a matrix dimension with the dimension n times n, with n greater than 2, we have to follow this step. The first step consists of choosing the row or column that I want to expand the matrix, okay? So we have the row or the column, we fix the row or the column that we want to use to expand the matrix. Secondly, there's a sign pattern that you have to follow. The sign pattern here is, if you start with positive, it generally start with positive. Then I will explain this later. You have to follow by negative, positive, negative, and so on. Okay? You have to use this sign table. You have to, if you start with, always start with positive, then the next is negative. You have to alternate between positive and negative. But you can put two negative signs consecutively. You have to alternate, okay? And the last step is to expand as per row. So you expand as per row. All right, these are the 3 steps that we want to follow when we have to expand a matrix n times n, okay, with n greater than 2. Because if n is equal to, you just do what I explained here with this example. That will be simple, straightforward. You don't need to choose any sign things, or you don't need to expand following a certain row or column. So as an example, we want to find this determinant, okay, the determinant of this matrix. Remember, I already explained that the notation, this bar means determinant, okay? So we want to find this determinant. And as I explained here, we have to choose to expand following a row or a column, okay? So let's start with the first column. We have this determinant. If I fix the first column, then this is 1, is plus 1. If you cross this twice, okay? So if I cross this, and I also cross this twice, so I cross this number twice, that's why we have plus 1. Is the first position is plus 1. You remain with this 4 entries. So this is 2, 1, 3, 4. Secondly, I want to cross this second part. I have crossed this. Okay, so this is still 1. So with the sign is -1. And we remain with this, and this. So 1, 2, 3, 4. And lastly, if I cross this last term, we still do this. And now we cross with this one. So crossing the last one, the sign here is positive, and we remain with these 4 entries. So this is 1, 2, 2, 1. So I want to find this. This is a 2 by 2, right? And it's very simple. We just have to apply this rule. 2 by 2, this is plus 1, multiply 2 times 4 minus 1 times 3 minus 1, bracket 1 times 4 minus 3 times 2. And we continue with the last one. This is 2 times 1 minus 2 times 2. So if we simplify this, we have this times this. This is 8 minus 3. This is 5. For the second one, this is 4 minus 6. This is minus 2. Minus 2 minus 1 is plus 2. And the last one is 1 minus 4 is minus 3. Minus 3 times 2 is minus 6. Okay? So it means if you simplify this, this is 1. This is a determinant we obtain with the expansion following the first row. If you use the second row, you obtain the same result. The third row, you obtain the same result. I don't want to do that. And we can also do the expansion following the column. Let me do this, repeat this calculation. I want to repeat this determinant, but with the expansion following the column, okay? I want to do my expansion following the first column. So I start with the first term. If I cross this, this is what we have. It's still first one. This is plus 1. And I remain with 2, 1, 3, 4. Secondly, I cross this second term. This is minus 1. And if I do that, I will remain with this 1, 2, 1, 4. And lastly, I cross this 2. This is plus 2. And I will remain with 1, 2, 3, 2, 3. If you expand this, then you will obtain exactly 1. So if you take this, this is 8 minus 3 is 5. 4 minus 2 is 2 times minus this is minus 2. And the last one is 3 minus this, minus 4 is minus 1. So this is minus 2. And this is 1. This is equal 1. So you see that either you choose to expand following the row or the column, it doesn't matter because we end up with the same result, okay? Now, let's look at another matrix here. Let's take a case of a 4 by 4 matrix. Third example, example 3. Let's find the determinant of the following matrix. So, as I say, the expansion doesn't matter. I mean, the column or the row that you choose to do the expansion doesn't matter, okay? Because I generally choose the row or the column that contain zeros, okay? If I choose to expand following the first row, the third row and the fourth row, I only have 1 0 in my expansion. So I want to have as many as possible. So if I choose to expand following the first column, second column, and fourth column, there's not 0 at all. And that can't help me, okay? So if I want to go quicker, I can expand following this third column, okay? If I expand following the third column, we say the first sign here is, if we say negative, this is positive, negative, positive, negative, and here is, this is negative, positive, negative. So this is negative 2, and if we cross this 2, if I cross this twice, as I explained, then what we didn't cross is 1, 2, 3, 1, 1, 2, and the second one is 1, 2, 3, and the last one is 2, 1, 4. So this is basically the same matrix as we obtained this matrix. This is exactly this matrix, okay? And we know that is 1, so this is minus 2 times 1. This is minus 2, okay? So this is what we have for this simple case. It's very important to wisely choose your column or row that you use for the expansion, okay? Now, if you want to generalize this, let's consider a matrix A with a dimension n times n. So it means the number of rows is n and the number of columns is also n. So I want to find the minor at the entry A, I, J, because my matrix is made of A11, A12, and so on. So I want to find the minor at this. By definition, the minor Mij at this position is just a n minus 1 times n minus 1 matrix, okay? And how about the cofactor? Cij is just giving, we just use the minor. If you are finding the cofactor at the same position, okay, this is just minus 1 to the power I plus j times the minor matrix. All right, if I want then to find the determinant of this matrix n by n, and I choose to expand following the row here, and the determinant will be the following. If the determinant of A is equal to the sum of j from 1 to n of A, so the entry, all right, the entry, remember, Aij is what we have here. This 1 is our Aij because it's the entry at the position 1, 1 for this case, times minus 1 to the power I plus j. So in this case, it is 1 because the row is 1, the column is 1. 1 plus 1 is 2. Minus 1 to the power 2 is 1. And we multiply by the minor. The minor here is just this matrix, okay? 2, 3, 1, 4. This, as we define the cofactor, if you want to use the cofactor, this is just the sum of j from 1 to n, Aij, cofactor matrix. Then, if I choose to expand following the column, so it means I'll fix j, okay? Determinant of A is equal to the sum following I now, okay? From I from 1 to n, Aij minus 1 to the power this, the minor Ij is equal to the sum of from 1 to n, Aij, Cij. Okay, so expansion following the row, I use this. Expansion following the column, I use this. As application, let's find the determinant of the following matrix. Let's call this example 4. Find the following determinant. Okay, as I say, I can choose to expand following the first row, second row, or third row, or the first column, second column, and third column. So in this case, what do you prefer? Let's expand following the second row, and we use this definition. This is the sum of j from 1 to 3, okay? If we apply this formula, because it's this, so I is equal to, in our case, then this is entries A to j times minus 1 to the power 2 plus j, okay, m to j. You can still write it as the sum of j from 1 to 3, A to j, C to j. Then let's expand and see what is A. If we start with this second row, as I say, second row, so A to j is 3, right? At this position, j is 1. If j is 1, then we have 2 plus 1 is 3. 1 minus 1 to the power 3 is minus 1. So we put the negatives here in front. And the minor here is 2 minus 1, 3, and 2. Secondly, we move to this, we cross this second term, okay? So this is 1, and the sign is 2 plus 2. Minus 1 to the power 2 plus 2 is plus. And we remain with 1, minus 1, and 2, And the last one is this. The sign will be negative here, 1, because we have 1 here. A here is 1. And we remain with 1, 2, minus 1, 3. All right. At this stage, we're almost done, okay? We just have to expand as a simple 2 by 2 matrix. We have to expand here. This is minus 3. This is 4 plus 3. And this one is plus 1 times 2 minus 1. And the last one is minus 1 times 3 plus 2. If we simplify this, we obtain minus 25, okay? So we choose to expand here following the second row. If you choose the first row, the second row, or the first column, second column, or third column, you end up with this same solution, okay? So it doesn't matter. As I say here, the choice of row is depend on the facility that the row or the column will give you. If I have zeros entries, then I would rather choose the row or the column that contain the highest number of 0, so that it can make my expansion easy, okay? Because if the entries are 0, in this case, you see that it will make the matrix easy. 0 multiply any minor terms or any cofactor will always be 0. That's why we wisely choose the column or the row that contain the highest number of 0 in the matrix to do our expansion. This is all for the introduction of the determinant. So in the next videos, I'll give you more example and some properties of the determinant, how to find a determinant using the Gauss reduction, and some properties that apply to the determinant to make things easy, okay? So I look forward to seeing you in the next video. Thank you.